Have you ever looked up at the sky and seen a machine hovering in one spot like a dragonfly? That's no airplane. Airplanes are amazing, but they need to keep moving forward to stay in the air. They have long, fixed wings that cut through the air, creating lift. To take off, they need a long runway to build up enough speed. A helicopter, however, is a completely different kind of flying machine. It can go straight up, straight down, forward, backward, and even sideways. It doesn't need a runway at all. It can take off and land in a very small space, which is pretty cool if you ask me. This unique ability makes helicopters incredibly special and useful in ways that airplanes just can't be. The secret to this incredible flying trick lies in how helicopters generate lift. Instead of fixed wings like a plane, a helicopter has wings that move. Think about it. They are giant spinning blades on top, sort of like a huge ceiling fan. These blades are called rotor blades, and they are the heart and soul of the helicopter. While a plane uses its forward speed to make airflow over its wings, a helicopter creates its own wind by spinning its blades really fast. This spinning motion is what allows it to lift off the ground without moving an inch forward. It's a brilliant piece of engineering that turns the principles of flight completely on their head, or rather, on their top. This difference in design is everything. An airplane is designed for speed and distance, soaring high in the atmosphere to travel between cities or countries. It's a master of the long journey. A helicopter, on the other hand, is the master of precision and versatility. It can navigate through tight canyons, land on the top of a skyscraper, or hover steadily over a single point for a long time. This makes it perfect for jobs that require a delicate touch from the air. This fundamental difference in how they fly and what they are designed to do is what sets these two amazing types of aircraft apart. One is a sprinter, and the other is an acrobat. So the next time you hear that familiar womp 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 sound in the sky, you'll know what you're seeing. It's not just a noisy machine, it's a marvel of science that has conquered gravity in a unique way. It's a vehicle that dances with the air, using spinning wings to perform feats of flight that seem almost impossible. Understanding this key difference between a helicopter and an airplane is the first step in appreciating just how incredible these flying contraptions truly are. From their appearance to their very purpose, they are a testament to human ingenuity and our endless quest to master the skies above us. Let's take a closer look at a helicopter piece by piece. It's like a science kit, where every part has a very important job. The most noticeable parts are the long, slender blades on top. This is the main rotor system. These aren't just simple blades, they are carefully shaped airfoils, just like an airplane's wings. They are designed to slice through the air in a very specific way. Connected to the main rotor is a powerful engine, which is the muscle of the helicopter. The engine provides the energy needed to turn the main rotor at incredible speeds, creating the force necessary for flight. Without that powerful engine, the blades would just be sitting there, not doing much of anything at all. Now look at the back of the helicopter. You'll see a long boom, and at the very end of it there's a smaller, sideways propeller. This is called the tail rotor. It might seem small, but its job is super important. When the main rotor spins in one direction, Newton's third law of motion tells us that the body of the helicopter wants to spin in the opposite direction. The tail rotor pushes air to the side, creating a force that counteracts this spinning motion and keeps the helicopter pointing straight. Without the tail rotor, the pilot would just be going for a dizzying, uncontrolled spin, which wouldn't be a very fun or safe ride. Inside the helicopter, you will find the cockpit. This is the control center where the pilot sits and works their magic. It looks a bit complicated with lots of dials, switches, and two very important controls. One is a stick that comes up from the floor called the cyclic. Another is a lever next to the pilot's seat, called the collective. These controls allow the pilot to communicate with the rotor blades, telling them how to move, and therefore, how the helicopter should fly. The cockpit is the brain of the helicopter, translating the pilot's commands into precise mechanical actions that control this powerful machine. All these parts have to work together in perfect harmony. The engine powers the main rotor provides the lift, the tail rotor provides stability, and the pilot in the cockpit directs the whole show. It's a beautiful symphony of physics and engineering. The body of the helicopter, called the fuselage, holds everything together and carries the passengers or cargo. Every single bolt, wire, and blade is designed with a purpose, contributing to the helicopter's amazing ability to defy gravity. Understanding these key components is like learning the secret language of helicopter flight. So how do those spinning blades actually lift a heavy machine off the ground? It's all about a science principle called Bernoulli's principle. Consider this: as the rotor blades spin, they are shaped to make the air travel faster over the top surface than it does underneath. They are curved on top and flatter on the bottom. According to Bernoulli's principle, faster moving air has lower pressure. This means the pressure of the air above the blade becomes lower than the pressure of the air below the blade. This difference in pressure creates an upward force. It's like the air below is pushing up harder than the air above is pushing down. This upward force is called lift. When the helicopter is on the ground, the pilot starts the engine, and the main rotor begins to spin faster and faster. As the speed of the blades increases, the amount of lift they generate also increases. The pilot can control the amount of lift by changing the angle or pitch of the blades. By pulling up on the collective lever, the pilot increases the pitch of all the blades at the same time. This makes them bite into the air more aggressively, creating even more lift. When the force of lift becomes greater than the force of gravity pulling the helicopter down, the helicopter lifts off the ground. It's a delicate balancing act. To hover in one spot, the pilot adjusts the collective so that the upward force of lift is exactly equal to the downward force of gravity. The two forces are in perfect balance, and the helicopter hangs there in mid-air, seemingly by magic. To go up, the pilot increases the pitch of the blades to generate more lift. To go down, the pilot decreases the pitch, reducing the lift and allowing gravity to gently pull the helicopter toward the ground. It's an elegant dance between the power of the engine and the fundamental laws of physics. Think of it like this: each blade is a small wing, and by spinning them in a circle, the helicopter creates its own continuous airflow. It doesn't need to race down a runway to get that airflow, it makes its own right where it stands. This is the fundamental genius of the helicopter design. It uses rotational motion to create the linear lift needed to fly. This principle is what separates it from all other aircraft, and gives it its unique capabilities, allowing it to become a master of vertical flight and stationary hovering. Science is amazing. Getting off the ground is one thing, but how does a pilot steer a helicopter? This is where the other control stick, the cyclic, comes into play. While the collective changes the pitch of all the blades at once to go up or down, the cyclic changes the pitch of each blade individually as it spins around the circle. If the pilot pushes the cyclic stick forward, the blades will increase their pitch as they pass the back of the helicopter and decrease it as they pass the front. This tilts the entire rotor disc forward, causing the helicopter to move forward. It's like tilting a spinning top to make it move across the floor. This same principle applies to moving in any direction. If the pilot wants to fly to the right, they push the cyclic to the right. This tilts the rotor disc to the right, and the helicopter follows. To go backward or to the left, the pilot simply moves the stick in that direction. And what about turning? The pilot uses foot pedals that control the tail rotor. By pushing a pedal, the pilot changes the pitch of the tail rotor blades, making them push more or less air. This allows the pilot to precisely control which way the nose of the helicopter is pointing, enabling them to turn on a dime while hovering or flying forward. It's an incredibly responsive system that requires a lot of skill and coordination. This level of control makes helicopters unbelievably useful for jobs that other vehicles simply cannot do. Think about a mountain rescue mission. A person might be stranded on a narrow ledge where no airplane could ever land. A helicopter can fly in, hover steadily just feet away from the cliff face, and lower a rescuer down on a winch to bring the person to safety. They are also essential for fighting fires in remote forests, delivering emergency medical supplies to disaster zones, and providing news coverage from above a major event. Their ability to get into tight spaces and stay put makes them true lifesavers. In the end, a helicopter is more than just a machine. It's a symbol of versatility and a tool that extends our reach into places we couldn't otherwise go. From the powerful engine to the precisely angled rotor blades, every part works together to perform an aerial ballet governed by the laws of physics. They can lift, hover, and maneuver with a grace that defies their mechanical complexity. By understanding how they cleverly manipulate air pressure and direction, we can see that helicopters don't defy gravity, they master it. And that, my friends, is what makes them such amazing and indispensable flying machines.